Okay, here we have some questions on equilibrium. So we've got carbon monoxide reacting with oxygen to produce carbon dioxide. We've got plus 564 kilojoules. Because that's on this side, that means the reaction is exothermic because heat is generated. Okay, if it is at equilibrium, what would be the effect of increasing the temperature on the concentrations of all species? So if you increase the temperature, that's going to go up. If that goes up, then let's have a look here. If that goes up, it's going to drive the equilibrium this way. That means this is going to go up, that's going to go up, that's going to go down. So, once again, the way it's written, this is an exothermic reaction, so energy is written as a product. If that particular product, the energy, is increased, and we're talking about temperature, so that's energy, the system will shift to the left to try and minimize the change as per Le Chatelier's principle. Therefore, the concentration of CO2 is going to go down because the equilibrium is shifting that way. These concentrations will go up. Okay, the rates of the forward and reverse reactions. So immediately after increasing the temperature, the reverse reaction rate is going to increase because, again, the equilibrium is shifting to the left. Realistically, both rates of reaction are going to increase because we've got higher energy, so I've got more collisions, I've got more energy available to overcome the activation energy requirements, so both forward and reverse reactions will increase. However, the reverse reaction will increase the most. Again, as per Le Chatelier's principle, minimizing the change. Okay, another equilibrium reaction. We've got sulfur dioxide plus oxygen going to give sulfur trioxide plus 99 kilojoules. So once again, this means that is an exothermic reaction. That could just be written as delta H equals minus 99 kilojoules, which would mean, again, that it's exothermic. So what would be the effect of adding a catalyst? Alright, catalysts speed up they decrease the time needed for equilibrium to be reached. However, they don't actually affect the equilibrium position. So, what would be the effect of adding a catalyst before the system reached equilibrium? This means equilibrium would be reached in a less time. That's all. It'll be faster to reach equilibrium. After the system reached equilibrium, well, the catalyst speeds up both reaction rates, but it speeds them up at the same rate. So after the system reached equilibrium, adding a catalyst has no effect on the actual equilibrium position. Alright, let's have a look at this one. We've got a bottle of soft drink is opened and half of the contents consumed, then the cap is screwed back on the bottle. Some time later, the bottle is opened and the rest of the drink consumed. This portion of the drink tastes significantly flatter than the original, that is, there is less fizz in the drink. Explain why this is so. We need to have an equation before we can actually do that. Okay, we've got a bottle here. When they actually make the carbonated drink, they put a high pressure of carbon dioxide up here, and that forces this particular equilibrium to the right, so we have aqueous carbonic acid in the actual soft drink. Now that was because, again, when they make this, they increase the CO2 concentration. That reacts with the water, drives the equilibrium across to the right-hand side, so we get a high concentration of carbonic acid in the actual soft drink. As soon as you take off the lid, that releases this extra CO2. So this concentration drops. That means the equilibrium shifts this way to try and minimize that change as per Le Chatelier's principle. Therefore, the amount of carbonic acid in the soft drink goes down, and this keeps on happening. Keeps on because the CO2 is continually released here. As that is lost to the atmosphere, the equilibrium keeps on shifting this way, so that carbonic acid is gone, and therefore the whole thing is flatter. and it all comes down to the CO2 escaping. If that concentration goes down, the equilibrium keeps on shifting here. Shifts over this way, CO2 drops. Keeps on shifting, CO2 drops, because it's just escaping into the air until we reach a new equilibrium. But that new equilibrium is based on the carbon dioxide gas concentration in the atmosphere. So realistically, there's not much carbonic acid if you leave it long enough, because the equilibrium is just with the CO2 from the atmosphere.